Hello everyone. In this video, we are trying to see how to connect 8051 microcontroller. In specific, we are having ESA MCB 51 kit. So we are going to see a small introduction of that kit and what are the programming procedures we have, so that we can able to do a programming from Keil C51 and you can able to make that program to run in 8051 microcontroller. So this is an introductory video. So we will just see what are the capabilities of ESA MCB 51. So this is what we are going to do in your lab. So it is have an on-chip flash monitor, provides communication with Keil. So executes user programs at full speed, debug the programs using a single-step breakpoint facilities available in your Keil debugger. After that, we are having an onboard LCD 16x2. So we are having an LCD screen, so in which we are going to have in terms of two divisions, which is going to be having 16 here, and we are going to have one more 16 here. So this is one and this is two. Like this, we are having an two LCDs, which is going to be attached with each other, so that we can able to see the characters in your 805. So after that one, we are having 32 input-output port lines terminated at 4 different 10-pin connectors. We will see while we are moving into the diagrammatic explanation. So which is going to be used by us is going to be port 0, port 1 and port 2 only. So other ports we can't able to use it because it is already being used for some other purpose. So CPU signals we are having in terms of 40-pin connector. So on-chip ISP support, so on-chip flash programming. So all these things we will be seeing while you are getting into programming also. So what is the processor we have? So it is going to be AT89C51ED2. So this is what you have selected while you are doing programming in simulation, right? So while you are getting into Keil, so you have selected this hardware. So this is why you have selected that hardware at that point of time. So it is going to be working the megahertz of 11.0592. So all of the things 64K, 256 bytes of RAM, so 1792 bytes of XRAM, 2K bytes of ERAM, EEPROM. So all those things are being attached in the kit itself. So we are having three 16-bit timer bar counters. We are having. So after that one, we are having a watchdog timer. We are having a program counter on port 1, and we are having full duplex enhanced UART communication. So this is how it is going to be interfaced with your PC. So you are going to communicate with your PC and as well as your using Keil program. We are going to send the program to 8051, right? So this is going to be in terms of serial communication using your USB. So we will see how we are going to interface those things. So in specific, in terms of interrupts, we are having 9 sources of interrupts. 2 interrupts are having in terms of buttons in your kit itself, which is going to be interrupt 0 and interrupt 1. This is an push button which is going to be enabled. So we can able to see that in your kit. So we can able to use it for any application while programming. So in terms of block diagram, you can able to see all the communications, and in terms of memories, all those things are interfaced in your AT89C51 ED2 RT2 microcontroller. So we are having LCD which is already interfaced, right? So that should be having specific input output ports which has to be connected to your LCD, right? So the pin of port 3, port 3.7, 3.6, 3.5, and as well as port 2.7, all those things is going to be already interfaced with your LCD. So whenever you are not going to use that one, you are going to use it for some other. So which is going to be available in terms of 26 pin. For your external peripherals, we can able to get it in terms of connectors. We can able to do in terms of port 0, port 1 and port 2 is available for us. So here UART communication, which is going to be serial communication. So it is going to be interfaced with your RS-232 in terms of your PC. So it is getting communicated with your PC with your Keil. So we have seen a problem while we are discussing in terms of theory. We have seen a problem like what is the problem in terms of TTL logic from 8051 and what is the problem to communicate with your PC with this TTL logic, right? So in order to eliminate that, we are having a few ICs also, so that we can able to eliminate those problems while you are communicating with your serial communication UART protocol to RS-232 protocol. So with this basic block diagram introduction, we can move into your kit, how it is looking like. So this is your power pin, which has to be connected to your power card. So it has to be given with an adapter. So you have to connect it with your power source. And after that, we are having an switch so that we can able to move from execution mode and program mode. Execution mode. So while you are going to attach along with your Keil at that time, the program is going to be running from Keil and it is just going to execute it. While it is in programming mode, so we can able to disconnect from your Keil and it can able to run individually. So in our lab purpose, we will always do execution mode. So we are going to interface along with your Keil, and Keil is going to be giving the programs and your kit is going to execute the program. So after that one, I have said that we are having ports for external communication, right? So what are the peripherals we want to communicate? So it has to be attached to this port. So this is going to be port pins. So each and individual port is getting interfaced in terms of each and every pin. We will be having a detailed explanation of this pin. So where you will be understanding about which pin is going to be corresponding to which port and which pin. So all those things is directly given. So can you directly take it from that. And after that, we are having an LCD screen. So it is going to be 216 bits. So it is going to be looking like this. So in top, you can able to have some characters. In bottom also, you can able to have some characters. So we can able to do this one. And after that, we are having, I have said that we are having interrupts, right? So interrupt 0 and interrupt 1. And in terms of pin diagram, we can able to see it is interfaced with port 3.3 and 3.2, which is going to be already interfaced with interrupt buttons. So whatever we are going to give in terms of interrupt, I can able to get it in terms of this port pin. So after that, we are having a reset button to always reset. And after that, we are having an PC connector. So UART to RS-232 protocol. So we are going to communicate with your 8051 to your PC. So whatever you are going to send it from Keil, there will be an USB which is given to you. So you have to attach that USB to this one so that it can able to send the programs from your Keil to 8051 kit. So that mismatch in terms of TTL logic is being corrected by your MAX 232N and separate IC which is given to your microcontroller. So we are having an oscillator which is going to produce the clock frequency which is going to be here. And after that, this is our hero EMU8086 C51 ED2. So this is your core which is going to be in terms of 8051. All other things are going to be peripherals so that it makes our programming to be very easy, and in terms of hardware to be very easy for us to communicate with your 8051. So while you are seeing it, so we are having two interrupt buttons, which is there here and here. After that, I am having port pins to communicate with your external world in terms of input and outputs. And I'm having execute to program buttons, and I'm having an thing in terms of power button, and I'm having my processor here and my oscillator here, my MAX 232 TTL correction in terms of RS-232 and UART, and I'm having an plug which is going to be connected in terms of USB to your PC. So you have to make sure that you are giving a power supply along with this USB is given to your kit. So this is a basic thing which you are going to see in terms of your 8051 kit. So different manufacturers are going to provide different kits. So I am giving an just general things which is going to be in terms of ESA MCB 51. So I have given this complete description of its book, reference books and other things in the link below in the description. So you can able to go to that and you can able to read it furthermore if you want to understand more. So which are the pins? We have seen like many pins are there, right? So if you are going to search, get the first pin. So it is going to be connected to port 2 and fourth pin. So if it is going to be second pin, so it is going to be of port 2 and pin 5. So I have already said we can able to access port 0, port 1 and port 2 of your 8251, right? So if you want to access port 0, so I have to take it like this. So if it is going to be port 0, so I can able to see port 0 is here, 0.0 pin. So 21 is a pin which is going to be 21 pin is going to give the output of port 0.0, and 22nd pin is going to give the output of port 0.1. So I can able to make it as an input port, I can able to make it as an output port, all those things we can able to do. But all these things I can able to give a specific pin number, so that corresponding pin is going to be getting active. So we are having 26 pins. So all the 26 pins are given with exact ports. So if you want VCC, I can able to directly take it from 25th pin, and if I want to connect it to ground, it should be 26th pin. So in detail, we can more particularly we can able to move to a specific pin diagram also. So port 0, 21, 0th pin, 22, port 0, pin 1. So if in case if you are going to port 1, so 13th pin is going to give your port 1 0, and 14th pin you will be using your port 1 and pin 1. So like this I can able to move to the specific locations of your pins, and I can able to make it as an port. So it is already being designed for us, which make our programming very easy for our. So this is how your pin is going to look like, right? So we have already seen. So we can able to see this projection here. This is our reference. We can able to keep it as reference. So this is going to be, if you are going to take it from this, if you keep it on looking on your side, so you are going to being here. So you can able to look it from here. So this is going to be 1, this is going to be 2, this is going to be 3, and this is going to be 4, this is going to be 5, this is going to be 6. Like this, I can able to move to different instances, and this will be my 25th pin, and this will be my 26th pin. Right? So for reference, it should face your you. So like the same, it should also face you, so that you can able to calculate exactly how it is being done. So this is your pin 1, this is your pin 2, this is your pin 3, this is your pin 4. So exactly you can able to see here, right? This pin, and this is your pin 25, and this is your pin 26. So in this case, we can able to see how we can able to do that. So there is one so this is not the correct thing. So in terms, this is going to be your pin, right? So not the correct. So this is going to be your pin 1, this is going to be your pin 2, this is going to be your pin 3, pin 4, and this is going to be your VCC 25, and 26 is your ground, right? So like the same, I can able to interface it, and I can able to use it. So I have to plug this one over this one, and I can able to connect it to external peripherals, whichever I'm going to connect it to. So after that one, we will try to see and detailed procedure how you can able to interface this one. So we have already seen these things, right? So first, how to create a project and other things we have seen. So just a quick glance, I will try to make those things ready. So I will just shift between your PPT as well as your Keil, so that you can able to understand more from that one. So first open your Keil. So I have already opened that one. After that, create a new microvision project. So in that you can able to go to your project. So you can able to create your new microvision project. So it is going to ask your name. So any name you can able to give without any extension. So I can able to give it as sample one or something. Right. So after that I have saved it. So it will just ask what kind of hardware we have to give it here. So we have already given with hardware 8089 C51 ED2, right? So I can able to type it, and I can able to directly get it 8080. So it is going to be 8080 C51, and exactly that here, right? ED2 89, sorry, 89C51, and after that it is going to be ED2, right? So I can able to check it. If you want to go, you can able to go to microchip and you can able to select this option also. Sometimes you will not get these options, so you can able to directly click it here. You will be having LLC legacy. After clicking on LLC legacy, you can able to type the same and you can able to get that. So you can able to get the description of those products. We have already seen all these things in your introduction itself, right? So just click on it and click OK. So it is going to ask something. So copy a startup startup.a51, right? Click no here. So this is what is given in description also. You can able to check LLC legacy, click OK, and after that is no. And after that, you have to create a new file, enter the file name with ASM extension, right? So you have to click a new file. So after that, we have to save that file. So if you want to save that file, we have to give a name for this one. So we can able to click on new file, enter the file name with .name extension, right? So after that one, this is going to be your text file. So with this one, we have to save it. So you can able to save with an ASM extension. So I can able to type it as anything. I can able to type it as some interface or something, and .asm. I can type with ASM extension, and after that I can save this one. So it is then now it is in ASM extension. So I can able to make use of that one. So after that one, what is the thing which I have to do? So create a file, and after that plus symbol near your target folder, and right click on the source group. The symbol, right click on your source group, add existing file to that group, and you can able to go to that existing program which I have typed, which is interface, right? So I can able to click on interface and able to click on it. So while I'm clicking on it, you can able to add it. After that, you can close it. So you can able to click on this one. You can able to see whether it is getting interface, right? So this program is getting coming under the source group now. So I'm okay, and my program is ready for my execution. So with this one, we can able to just see other things we have completed. So here it's completed. After that, existing create an .asm file, add, close. After that one, we can able to save all, right? So I have done till that point. So next one, what are the things we have to do? Create a new file, enter the file name with the ASM extension, target folder, all those things we have completed, right? So after that point, what we have to do? So in previous programs, what we have done an program, and after that we have tried to get an thing in terms. We will try to enter some program like org 000h. So assume I'm giving this program, and after that one, it is going to be your something, and I'm going to end this program here. So clear C2.3. So I'm just trying to clear some port. Just assume that one. So after that one, I'm saving this one. I'm just keep on running this one, right? So here, but while you are going in terms of hardware programming, before that executing, so you are going to see the things in terms of hardware. It's not software now. So you have to click on this options for target. So click on options for target button, and after that one, click on options for target. So after that one, while moving into device, make sure your 8089C51 ED2 is getting selected. So it is already selected. So there is no issue. So after that one, move to target. So at this point of time, you are going to see that your clock cycle is not going to be in terms of 11.0592, right? So just see here. So 11.0592. So 11.0592 megahertz, right? So this is done. So after that, I have to enable my use on-chip ROM and use on-chip RAM. Both things I have to select it, and this is with respect to the target. And after that one, in terms of output, so there is one button which is being disabled, which is going to be create hex file, right? You have to enable that also. Create hex file should be enabled. And after that one, we can able to move to debug. So in debug option, you can able to see simulator is being used, right? which means you are going to do programs in terms of simulation, but hereafter we are going to do in terms of hardware, right? So this simulator should not be used. So output option, create hex file, and after that debug option, use Keil monitor 51 driver. Right? So click on use. After that, here you just try to use Keil monitor 51 driver, enable that one, and after that one go to settings. So here you have to understand in which port your 8051 is getting connected. So if you want to understand in which port it is getting connected, go to your device manager. So now your 8051 is not connected, so it will not show any port. So if I am connecting that one, just for your understanding, I am connecting my pin now in my USB. So it is getting refreshed. So after that one, I can able to see and port which is getting enabled, right? So there is one option called as port. So if you are going to click on that port, so USB serial port COM3, right? So my processor is getting connected in COM3. So if that is the case, close this one. So you can able to select your COM3, and after that fix the baud rate as 9600, right? I am having many baud rates. So which is going to be communicating between 8051 and your PC is going to be 9600 baud rate. Click OK. So that's it. So we are ready for loading our program in your 8051 device. What are the things we have to make sure? Device, whether the device of 8089 C51ED2 is getting selected, and after that one move to target. In target 11.0592 should be there in your clock frequency, and after that use on-chip ROM and on-chip RAM. Both the things has to be selected, and after that while going to output, you can able to see create hex file has to be enabled, and after that one go to debug. In go to debug, instead of using simulator, use Keil monitor 51 driver. In going to settings, understand in which COM port your 8051 is getting connected, and after that select that button, and after that you can click on OK, right? And after that press OK. So now everything is clear, so we are ready for our programming. So overall, we can able to save it, we can able to save this program, and you can able to directly enter into debug mode. While we are entering into debug mode, all the things in terms of output we can able to see inside your hardware kit, right? This is what the basic things which you want to understand before moving into hardware programming of 8051. So as a nutshell, so I can able to say what are the things we have seen till now. So we have understood what are the capabilities of ESA MCB51 is. After we have seen the block diagram. So we are having a power pin, execute board program switch, port pins, LCD screen, interrupt 0, interrupt 1, reset. So PC connector in which your Keil programming has to be downloaded. So max 251 for TTL logic adjustments, oscillator, Atmel 8089 C51ED2, so which is going to be here. So after that one, what are the pins and what are the ports correspondingly we have, right? So after that one, we are having these pins, right? So in this corresponding pin, so how it is getting connected? If you are going to directly connect it on it, we are having one more end which is left. So on that end, I can able to connect whatever device I want. So make sure that this is facing you, so that you can able to count it correctly and you can able to mark it in the perfect location. So a detailed procedure, all these things we know. So this is still this, it is going to be same as like your normal programming. So after this one, these are the things which you have to do. So click on options for target, enter your clock frequency, enable your on-chip RAM and ROM. After that, click on output option, enable create hex file. Click on your debug option, enable use Keil monitor 51. Click on settings, select your active COM port in which your device is connected. Check it in your device manager. And after that, enter the baud rate to be 9600. Click OK. Right? This is what an overall things which you want to do before getting into programming of 8051 hardware kit. So remaining things and uploading of program and other things we can able to see in your next program. Thank you for your patient listening.